Hello and welcome to this short video in which I will show you Cytely's new workflow builder. First I will start by creating a data set by dragging and dropping an image file onto the Cytely dashboard. Once it's uploaded, we can see what it contains. In this case we have HeLa cells that have been stained by a nuclear dye and an actin dye. Now I will go to the workflow builder up here. Here I get the option to either select a pre-made workflow, or I can create a new workflow from scratch. If I choose to create a new workflow, I will see the channels that were used to image the sample. We have a DAPI channel with the nuclear stain, we have a DAC channel which is just normal white light, and we have a FITC channel in which the actin stain is present. When I click the DAPI channel, I will see an image of what that channel contains. We can see that we have the cell nuclei here. So first I want to create a simple mask for the nuclei, so I will choose a node called segment cell nuclei. And here we can see the mask that we get with the default settings. Clearly it's not what we're looking for, so I will adjust the parameters we see over here to see if I can get a cleaner mask. We have max size and min size parameters. We have Gaussian blurring as well. We have how much signal to include. And a percentage to tweak the signal as well. So I will start with the percentage to increase it to 1 to see if I can get rid of the background noise. And it seems that I can. Next I will increase the window size to 32 to see if I can connect these kind of masks. And it seems that I can. So what we have now are masks that cover most of the cell, but we have some holes within the nuclei masks. So therefore I will add a new step called fill holes that simply fill out these kind of holes within the cells. We can see that we have some small objects here and there that we don't want to include into the mask. So I will add a new node called filter on size. So using this node, I can decide how big and how small the objects that I want to include can be. We can see that we miss a lot of the cell nuclei that we want to include, so I'm going to increase the max size to 20,000 pixels instead, and we can see that we include them now. We still have some small objects that should not be included in the final mask, so I will increase the min size to 500. And that gets rid of those small ones. So as simple as that, I have created a workflow that gives me not perfect, but good enough masks for my cell nuclei. Last step, I will add something called cell morphology, which is used to extract the morphological and intensity parameters of the masks that you see here. And this is then my final workflow. When I'm happy with it, I simply click Analyze All Files. And as soon as it's ready, I can see how many objects have been detected in this image up here, which is 84 detections. If I click here, I come to the Data Explorer tab. And here in the overview map, I can see exactly what has been detected in my image. And we can see that it is indeed the nuclei of the cells. Over here, I see thumbnails of the detections as well. If I deselect the FITC and the DAC channel, we can see more clearly that we have the nuclei here. We see that we have some cutoff cells and we have some double cells here. To get rid of those, we can produce a simple filter or gating. By using the 2D scatter plots that we have up here. So here I can select through the different parameters that we have extracted from the mask that we created before. For example, I can use the area, circularity, perimeter, or any of the channels that are included in the image. I will use area versus circularity in this case, and I get something that looks like this. We can see a hint of a population up here that I think is the population I'm interested in. So I'm going to select that like this. And we can see that we have a much cleaner population already. We still have one cutoff cell here. I could probably adjust this gate a bit more to get rid of it, or I can simply use the fact. So this cutoff cell is most likely a cell that's on the edge of the image. So I will use the coordinates of the cells to get rid of it. And like this, I can exclude all of the cells that are on the edges. Let's try another type of sample as well. So I'll go back to the start page of my Cytely dashboard. This time I will choose blood cells and neutrophils more specifically. Again, I will go to the workflow builder and I will create a new workflow from scratch. Here we have a DAPI channel, a nuclei channel. Again, we have a FIDC channel, which is a membrane stain in this case, and we have a Cy5 channel, which is a cytosolic dye. I will start by segmenting the nuclei of these neutrophils. I will use the same algorithm as last time, which is segment cell nuclei, like this, and now I should have one mask per cell. Next, I want to use the membrane dye to get the mask for the entire cell. Now I will use an adaptive thresholding, and we'll get something that looks like this. There are a few holes and it's not really connected everywhere, so I will increase the window size to 96. And we get something that looks like this. We have some holes in the masks, so to get rid of those we use fill holes, just like before. We now want to split up these stuck together cells. I'm going to use something called flood fill, in which we use the nuclei as seeds to tell the program where to split the cells. So here I have connected the seeds to the flood fill node, and I will also connect the cell mask to the same node. And we can see how we split up the separate cells here. So now that I'm happy with this workflow, I will add, as before, the cell morphology node. But in this case, I will use cell morphology 3 because I want to include 3 sources. And then I simply run the analysis. And we can see that we have 25 objects detected in this analysis. So here we can see what we have detected. We have these neutrophils and we have the red blood cells that don't have a nuclei. Again, we can use area versus circularity to get single cells. Here we have, for example, one that's still stuck together. So to exclude that, I'm just going to select these cells instead. And as simple as that, we have identified the neutrophils in the sample and performed a single cell segmentation on them. So I hope I could inspire some of you with this short tutorial, and thank you so much for watching.